Okay, and we are back on the track. So welcome after a short break. Now I'm with Frank Delporte, who is senior technical writer at AZU. And Frank will deliver for us a presentation under a very good title, Unlocking the Potential of Bits and Bytes, Reducing Data Footprint for Cost and Effectiveness. Efficiency, sorry. And as always, at the end I will lead some short Q&A sessions, so don't hesitate, just post the question on the chat during Frank's presentation. Frank, let's make a show.
Okay, wow, give a show. I will try to do that. Thanks for joining. Yes, so I want to tell you about bits and bytes and more specifically about what I learned from experimenting with electronics. I think people can see my presentation. So I will try to explain to you how you can put numbers on a digital clock, and you can do that with hex value, and what the value of that hex value actually is and how it tells specific electronic components to show something. And we will use a little Vaadin application to illustrate that. I will also show you how we can put a smiley face on a LED display, on an 8x8 LED matrix display, and actually the happy face that you're seeing here, how that is controlled by this hex value and how it may look like some mystery to you at this moment, but it's really clear, as we will also learn from this web UI. And all that is inspired by a job I had several years ago at a company building information screens for trains, and that with the value CB, you can actually share a lot of information about the toilets that are available in 2 cars in the train. Who am I? I'm Frank Delporte. As you said, I'm working for Azul as a technical writer. I have some open source projects I contribute to, and I am also a blogger on my own website, but more importantly on fooj.io, the website for the Friends of OpenJDK, and I think we are all part of that big family. You can also find me on Twitter, not really active anymore, but more on Mastodon in the fooj.social instance. I've been programming since the 80s. Yes, I'm that old. And this was my very first computer, a Commodore 64. And thanks to that computer, I found the joy of combining software and hardware, because already at that time, I could control my Lego train with a relay board connected to my Commodore 64 and combine software and hardware and control them vice versa, which was a really nice experiment. And I found back a bit of that love when I joined Televic almost 15 years ago, a Belgian company building, amongst other things, these screens for trains, where you have a lot of information being exchanged between different systems on the train, and we will come back to that later. I said I'm a technical writer at Azul, so you can find me on docs.azul.com. That's one of the websites I maintain together with my colleague, where we share all the documentation, release notes, vulnerabilities which are fixed in the different releases of OpenJDK and our runtimes. If you want to know more about our products, how we deliver different versions of and distributions of OpenJDK. You can read more about that in this little book, OpenJDK Migration for Dummies, which is written by Simon Ritter, the CTO of Azul. But it's a very general book, so it's not a sales book for Azul. It's really a book about how you can learn about the different versions of OpenJDK, which distribution you should use, or what support contract. All that kind of information is available there. It's a free book. Get it from our website. Now, this little project from my son, I thought I had muted it, but apparently not. This is a project I made for my son, where he has this controller screen with JavaFX. and it has an API. So this little application, that was actually the start of my experiment with Java and embedded programming, combining software and hardware again, where I combined that on a Raspberry Pi. So this was my experiment board for almost 6 months, where I tried out several components, and you see this little number display that you also know from your alarm clock, and that's actually also something that I will use in this presentation a lot more. Now, all these experiments ended up in a book, Getting Started with Java on the Raspberry Pi. So if you're interested in controlling electronics with Java on a Linux system and learn more about how you can use Java another way on Linux than just doing server applications, then this is a very handy tool, a handy book to get you started. Okay, now it all started for me with this Hello World in electronics, which is actually blinking a LED. So that means if you are able to do this, that you have taken your first step into the world of combining software and hardware and controlling electronics. All this is documented on the website, I will mention later. But with this book and this presentation that I made around this topic of controlling electronics, I did several conferences, and in JSpring earlier this year, I saw a presentation by Holly Cummins where she was talking about greener and cheaper and nicer software, how you can make your software eco-friendly. And that was really an eye-opener for me because it actually relates to a bit of my topic, and I will come back to that later. So she was looking into the most eco-efficient language, and luckily with Java we're already on a good track. If you look into this chart, then you see that Java and C are very close, and Python is using a lot more energy, and that's actually coming from this study that has been done where different languages were compared to do the same kind of functionality. And there you see that Java takes 1.98 times the energy of a comparable C function, but Python, for instance, takes 76 times that amount of energy, and it also needs more time to do similar things. So with Java, we are already on an eco-friendly language. For the same kind of functionality, we are using less energy than most other languages. But what she also was talking about is servers running in the cloud and doing nothing, which is actually a pitfall for a lot of engineers. We love to spin up new servers to experiment with something new, but do we turn them off, or do we really dimension them correctly that they are being used at a high level but still doing efficient work? Because there are also a lot of servers who are doing efficient work, but only 5% of the time. So there are a lot of servers there that are actually not used, costing the company money, but also costing the ecosystem a lot of energy. So it's not just about money and electricity, it's also about waste, because servers which are not used a lot still wear out and needs to be replaced after some time. Now, because she was talking about this, it started to make me think about the data that we transfer. We are transferring a lot of data between our systems, and definitely in a microservice architecture. Are there other ways that we can make this more efficient, more eco-friendly? And of course, that's the story of this talk. So the answer is yes. And I want to tell you more about bits and bytes. Actually, I'm not a graduated software engineer. I did film school. So when I stumbled into software again after several years in the television world, my very first websites, that's how I learned that FF0000 is actually red, and green is the Fs in the middle, and blue is the Fs at the right. But what does this actually mean? What's behind these hex values? And it's ones and zeros, of course, because that's how computers do everything. They just use zeros and ones. Now, I can give you this table to explain you how you go from hex value 1 to the value 1 and so on. But I have a nice movie which is probably more clear and will explain you how this works. So if you start with a 0, that's everything's related to the power of 2, you start counting up. So as soon as you understand how this works, then counting with zeros and ones becomes very easy. And this value goes up and up by 1 just by shifting the ones and the zeros. Okay, I hope this is clear. Otherwise, there's a lot of tutorials available. But that actually made me think that if one byte has 8 bits, then within that 1 byte, we have actually 8 times a true and a false. And there's a lot we can do with that kind of information, because there are 8 booleans in 1 byte. And the number range that this represents goes from 0 to 255. And that's, for instance, the extended ASCII table. So every character from this table is represented with a value from 0 to 255. So this is 1 byte. Every character is 1 byte. And now back to that job that I had at Televic, and we were building these systems to show passenger information in trains. And on the train, there are several systems that need to communicate with each other. So you have this passenger information stream that we were building, but you also have a server for the toilets, for instance, that keeps the state of all the toilets and are they available, are they occupied. There's also a server for the doors, are the doors opened, and which doors and which car can go open at the next station. So all that kind of information needs to be exchanged between all the systems to show it to the passenger, but also to work correctly. And we also needed to show where there are places available, where there are toilets available. And if you look at such a data sheet of such a system, then you see that they are actually using a lot of these bits bytes systems. Like for instance, the train state validity in this example uses 5 bytes and has a lot of information. Like for instance, knowing if the train is driving faster than 3 kilometers per hour is one certain bit within those 5 bytes. So within that single bit that toggles between 0 and 1 will tell you if the train is faster than 3 kilometers per hour, and for instance, the exterior lights need to be dimmed. Now let's look at the practical example. If we want to show the toilet state in a train, and we want to show the toilet state in a train with 2 cars. So we have 2 cars, and the first car has a toilet, but it's out of service. So the out of service flag is 1. Now in the second car, we have a toilet which is not out of service, it's wheelchair friendly, and it's occupied. So all the information of these 2 trains these 2 toilets in 1 train are all gathered with 2 8 bits or 1 byte. So we have everything condensed in this one value, hex value CB, which is actually 203. If you would look it up in that ASCII table, it's the capital E umlaut. It's there, it's 203. So we know everything about the toilets in these 2 cars with 1 byte value. If we would do the same with JSON, we are all microservice developers. We love to use JSON. But if you would use JSON for that same information to have these 8 Boolean values, then you end up with 254 characters, which is a lot more than this one single byte, of course. And how you can use these bytes to represent data is something I learned from experimenting with this electronics. If you look again at that one single 7-segment display, which is called, so it has 7 segments to illustrate a number. Actually, there's 8 because there's also a dot here. So again, we have 8 Boolean values. Which of these segments are highlighted? So if we look at the value 6D, that's the one we're going to use, the hex value 6D, which is actually 01101101, this one. And we can read it here, how this represents actually 109, 6D. So all this information tells us actually that we want to put a 5 on the display. So it's these segments which are turned on. So with the value 6D, we can tell this segment which of the LED segments to be highlighted. And if you combine this into an electronic experiment, then you end up with something like this. And what's actually happening, and you see it more easily here, is so we have a Raspberry Pi, and with one data signal, we can tell this chip it's the value 6D, and it will turn on this 8 segments depending on the value that we have given it. So this one chip will translate that one hex value into 8 output signals, which can be controlled to control this little display. That's how it looks in the schematics. You can find the example in my book. So let's compare this with the same thing in XML, JSON, other data formats. So we have this one 6D, which we can use in our electronic experiment to put a 5 on this display. The value M, 1 character, 1 byte. Now again, if we go to another format like XML, that's how it would look like in an XML format. So for each of these segments, we would have an identifier and a value, but that's already 345 characters. And the same happens with JSON. You have a lot more, 250 characters. And you can even restructure your JSON, have it in another format, but again, it's more characters. Or YAML, which is, by the way, one of the worst formats you could choose to transfer data. And there's another one that I didn't mention yet, which is quite important because it combines a lot of the advantages of the formatted data structures while keeping it very small. A byte buffer, and I hope you heard about this, a proto buffer. The idea here is that you have one text file that defines the format of the content of your data, and this file can be converted to Java classes, to Python code, to whatever system you're using. But this proto file, this text file, is actually some kind of contract that you have between different services where you say, this is how we will give you the data. And if you look into the actual size of this data, so if you have the same kind of data, it's only 24 characters. And the advantage of a byte buffer is that it has some checks in there. So if the data would be messed up while being transferred, then you would know that it's not valid data anymore. If you want to play with the protobuffer, there is a website where you can do that, protobuf.pal, and here you can experiment. So you see the definition file on one side, the JSON data on the other side, and the actual encoded value that's being transferred between systems. Now, you don't have to believe me, but if you look at, for instance, in this article, LinkedIn has adopted protocol buffers, and they have seen that not only the amount of data being transferred has been reduced a lot, but also the latency. So it's very easy to parse this kind of data back to objects instead of compared to XML or JSON or other formats. So protobuffers are a bit of the best of all worlds. So they have still some structure in there, but they are compressed, they are reduced in size, and still have very reliable results. I have made some online examples that we can take a look at to compare all this data. So this is, for instance, a little application where you have the same data. So you recognize this XML and the JSON here and all these different formats. And because that's an other alternative that people sometimes suggest is zipping your data. So zipping your data before you send it and unzipping it on the other side. So if you execute this data, then you see that, for instance, the XML originally was 345 bytes in size, and you can zip it to 150. The JSON, the same thing. So if you're zipping your strings before sending them, then they also become smaller. My Grammarly is a bit annoying here. There's one thing you need to take care about is if you zip a small string, then actually it becomes bigger. So for instance, zipping a protobuffer string doesn't make sense. It is already compressed, and the zip system by itself also has some overhead. So here's the table, the overview. So from this 1 hex value to define the 5 on that segment display, we just end up sometimes with over 300 characters. So please be aware that those 8 values, those 8 true false values could actually be transferred with 1 hex value. Here a comparison between XML, JSON, YAML. The conclusion here is by Bruno Borges, Java at Microsoft, is that YAML is the worst format for everything. So never used it. That's his idea. And we can also, let's look at this. This is another example. We can just use the power of Java, the tool that we are used to use, to love, to help us in understanding the data. So I have this small example where you see that we define a 7-segment display with this 1 byte value. And that's all we need to know within our application. That's all the data we need to be exchanged. But we can create a lot of helper functions to understand what actually is inside this 1 value. So if you execute this code, and we will actually see that all these segments are lit, and I actually also have some kind of dummy output. Let's make it an ED, and ED should also highlight the button, the dot on the display. So you see that we now also have the dot. So we can use Java to translate those unreadable data again to something that we can, as a developer, understand and read. Because that's my main message of this presentation is, why should data between microservices be human readable? Of course, it's very easy if you start debugging a system that you can just check the data, what has been received, what has been sent. But having all this readable data, human readable data flowing between services, which just do automatic things, there's no human involved there. So it doesn't need to be readable when we transfer data. We can make it readable again in our logging. We can make it readable in our code. That's where we should have helper functions. But it doesn't really make sense to continuously send readable data between systems. That's my idea. That's my opinion here. And you can use other tools, for instance, to if you need to check on the wire, let's say, what's happening within a network, you can use tools like Wireshark. And Wireshark also allows you to create Lua files, extensions, let's call it, for Wireshark. If you have a specific type of network data that you transfer, that you can make it readable again, that it gets listed here as this is my kind of network data, and my data package and what it contains, so you can make it readable again here in Wireshark if you really need to debug between your services. That's only one tool that you can use for that. I have a little experiment. We went a bit over time before we started, so I hope I have time enough. Let's do a little experiment with Py4j, Vaadin, and Spring. Let's go fast through this slide. So Py4j is a library to control electronics on the Raspberry Pi. Go to py4j.com if you want to learn more about it. What it actually does, it's a library inside your Java application, which has native libraries that can control these pins on the Raspberry Pi. I am using for my experiments, it's standing here behind me, a little CrowPi, and this CrowPi has a lot of components pre-wired for you. So you don't need to put any wires in here, and you cannot mess up the wires. So that means if it doesn't work, it's your code which is not working and not the experiment itself. On the Py4j website, you can find example implementations for all the components of the CrowPi. That's actually the thing I used for my demo. And it's inside this project, Py4j/Py4j example CrowPi. And you see here that there are applications being developed or have been developed by students of Swiss University for all these components. I will also be using Vaadin, which is a very nice tool to build user interfaces purely in Java. And My experiment has several types of electronics communication, a digital output to put on a LED, a digital input to read the state of a touch sensor in this case, but these are the fun ones, the other ones with I2C, SPI, PWM, which are different types of communication with electronic components. Okay, again, this project, it's on my GitHub, of course, Vaden examples, and it has an application, and let's just look at one of the views, the LCD display. The LCD, if we go back here, I'll show you the camera. It's where you see hello Java conf on top. So that's 2 rows of 16 characters. So you see here that we have a text field for row 1, and we have a text field for row 2, and we have a button to set it to the LCD display. So that's all part of the code here. And go back, and then we have a service which is a Py4j service, which actually has all the code to control these components. So this is a Spring application. If you have used Spring before, you will definitely recognize how this project is structured and what you can do with it. So let's see what we can do with it. So I have this presentation, this application running on this CrowPy. You see it here. So we have a system which is running on Azul system Zulu 19. So I'm using Java 19 here, and I have all these different windows to control these components. So if let's go to the 7-segment display. If I put a 5 on the first, voila, then you see that we have here the 6D. So you recognize these bits and bytes, all these values that I talked to you before, you can see it here. If I go to the LED matrix and I put the smiley face, then this is the hex value that I showed you very early in the presentation at the beginning. Now, let's make this fun. We have a few more minutes left, I think. Let's open a second tab or browser or whatever, or take your mobile phone and go to this address, py4j.ngrok.dev. And at that moment, you should be able to control this device yourself. So the address is py4j.ngrok.dev. Let me put it in the chat. And if I check if someone is connected already, I have a few connections. And I can switch screen for a moment. Show you another screen. Okay. Let's see if something happening. Okay. And I think you hear in the background that someone found the buzzer. That's also one of the many components which are available here. And if you open one of the screens and someone else is sending an event, then you will also see in the logging that people are sending. Someone send a heart and a cross. So you see that things are moving. And of course, everyone loves the buzzer the most. As always. And you see, and this is just a fun thing to see that this Raspberry Pi, which is just a little PC of, I think, 30, 40 euros, has 2 gigabytes of memory, which is not a lot. It's a quad-core system. So it's a bit comparable to a Docker instance that is used by many developers for the Java application. But we now have at this moment 90 open connections to the system. And it's just a presentation of that you can test everything you know of Java also on a Raspberry Pi. And as a side effect, learn how you can use these bits and bytes to minimize the data that you're sending through your systems. Okay. Let's go back to the presentation. Good, we're here. Okay, I hope you loved the demo. People stopped using the buzzer, which is good, so I can continue. What's next? I invite you to go to my website or to fujay.io, py4j.com, webtechy.be, where you can learn more about all this, of course, and a lot of other topics about Java. Let me show you fujay.io. Someone's trying to play music behind me. Also, definitely take a look at fujay.io, the website for friends of OpenJDK, where you also find a lot of information if you look for a Raspberry Pi. Okay, that's the thing I wanted to tell you. Please rate my session, and let's see if there are any questions and if I'm still on time.
Yes, we are still on time, and I'm also looking at our chat, and there's no question. So your presentation was so self-explanatory, so good that no one. But maybe we'll just give a half of a minute for the audience.
And they're still playing with my buzzer.
That's right. Very fantastic idea.
So the thing is there behind me, and that's why you hear it so good.
I would say fantastic idea for demos.
It's a nice thing because we as Java developers always jump to the cloud if we want to try something, or we need a Linux system or whatever. But actually, these very inexpensive little computers, these Raspberry Pis, they allow you to run everything you do in the cloud. I have MQTT systems. I have done Spring development on there. I have JavaFX user interfaces, web development. So you can try out everything. There are even people combining a few of these Raspberry Pis into a cluster if they want to play with Kubernetes for the first time and experiment with Minikube, I think it's called. So yeah, it's a very nice way to learn. And that's, I think, something as a developer we all need to do, is keep learning and keep being up to date.
Okay, I look once again, and I don't see any question for you. So your presentation was the best, Frank. So thank you very much for your presentation and for your speech. Please don't forget to rate Frank's presentation using the QR code which you see on the screen, or using the stars under the video player. And we are slowly beginning the lunch break, so enjoy your lunch, and don't forget that we prepared for you the possibility to meet with top IT employers during our IT job fairs or IT Expo. So let's take this chance and meet with employees and see what's going on the market. So see you after the lunch break, and thank you very much for your participation. See ya.
Thank you. See you.